Looks like we're live! Looks like we're live! Okay, so we are assembling. Okay, we're assembling the new parts. So let me just hop into CAD here. Let's get CAD open. tinyCAD or tinycnc. Alright, so this is the design from yesterday. This is what we did. And I realized that this hole is stupid. This should actually be in the middle here, but I'm not really going to update it now. And then what's crazy here is, look, this is 4.8. I don't know what the hell I was thinking. And then this was 4.6. So, you know, just like bad design all around. But so we have, what do we have? So we have this part, which has the linear bearings in it, and we tapped these already. I didn't show it in the thing, but we tapped it. And then we're just going to put the set screws in, so you can do that. So we're going to get, here, M3 by 5 should actually do it. So let's just get this M3 by 5. Real short, guys.
I don't want to be seen.
Understand what all of this.
What does that mean?
No, I honestly don't know.
Does it not zoom in?
It does zoom in, but you zoom in like this.
Oh, jeez Louise, you're totally right. That's all that goes?
Yeah, it's not. I have a bigger lens, but
It's fine. Just so many cameras. You just love looking at yourself.
okay. So we got the things in, and you can tell there's some good friction here. So these aren't gonna pull out from the set screw. There's a little bit of friction, but I think that it'll be okay. Oh, there's like grease on this part. Okay, so we have these. Now we need to disassemble this thing. So we don't need any crimp. We're not doing any crimp walking. I need this thing. Oh, I'm so happy to be done with this design. This design was such garbage. Oh wait, this is the wrong one. Wait, how do I switch it? Switch, select stream, refresh. There we go. Okay. I need to visit Adam Savage's shop. Because, like, if he wants an M3 by 8 by 0.5 bolt, what does he do? People said you can remove these threaded inserts from the part, but it's like, what a pain in the butt that is. What a pain in the butt that is. Okay. Alright, so we need to cut these rails. I think now's probably a good time to cut the rails because... Okay. So we got these 4 bolts. M3 by 8. M3 by 12. Okay. And then here, I should just be able to do this. Okay, great. So you're going to install this thing. You're going to install it with these two. So the way that it needs to go is like this. That fits in there nicely. But I think what we want... Wait, hold on. See with this? I'm pretty sure... Yeah, I'm pretty sure... Wait. No, wait, hold on. That's correct. That's correct. That's correct. Yeah. Okay, so then you just want to put them in through the back. Like that. And then I'll get you an Allen key. Here's the Allen key. All right, what if we go to our variable studio? Hold on. Look at my girl assembling. You're on camera. Wait, do you not want to be on camera? Okay. All right, so what am I doing? I need to go to here. Variable studio. Barlen. 88.5. Is that right? Hold on, let's test that out. So if I go to Z, open a new browser tab. Wait, did that just flick off? Wait, I thought I heard that flick off. Okay, so we want to know from this face to this face should be 60. 60, oh, 68. Yeah, that's perfect. Okay, so this is correct. So we need to cut them to be 88.5. So okay, good. Installed. You just leave it there. So the next thing we're gonna do is we're gonna go cut this. This would be 88.5.
Your chair's broken.
I know. Okay. You'll learn this in class, but it is very important to understand that the blade that you cut with has thickness, and there'll be on every test. It's called the kerf. Anyways, the kerf. So anyways,
A or an E?
what? It's a K-E-R-F. Kerf. Okay, let me just. So
Thickness of a blade?
yeah, it's the thickness. It's basically okay. So I measured out 88.5. Right, I made this little mark here with the calipers. I scribed it. If I want to make this piece 88.5 millimeters, I have to cut on the right side of it. If I were to cut in the middle of it, it would end up shorter because the blade is not infinitely thick. There's no such thing as cutting right on a scribed line.
Mm-hmm.
You have to either cut on the left side or the right side, and you need to make sure it's the right.
Correct side.
Yeah, it's the correct one. Okay, so why don't we take the calipers and go cut this bad boy. I think I just want to use a hacksaw and then a file. So let's go back to the shed. Unfortunately, I don't have a setup. I love, in the future, I'm going to have a setup where it's like all networked. Like every room, I can just go boop, and I can do it from my phone, and I could just be my own, cameraman. I actually can control what scene I'm on from my phone, and I did have a thing where I could use my laptop and then stream here, but it didn't work that well. The audio got all desynced and stuff like that. Anyways, let's go. I kind of want to move this in, just because of the tripping hazard. Thank you. Okay, what else do we need? I think we just need a. It's 88.5. Remember that. I don't know where that. right. So, one operation done. We have 2 pieces that are about 88.5 millimeters. So we can put this back in here. And basically what's going to happen is it gets smoother when you do that. When you... Oh! 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 Alright, so that's the carriage. It doesn't really matter which side it's on, but let's do it like this. Pretty good. Pretty good. Okay. Oh, we forgot to do these threaded inserts. Hey, it's not your fault because I didn't tell you, but anytime you're like done soldering, make sure you turn this thing off.
Well, you didn't tell me.
No, yeah, I know. It just, it just could be a hazard.
Yeah, I didn't.
No, yeah. I didn't say.
It's your fault.
It is my fault. Full responsibility.
Why are we going to the sunroom?
Oh, did you want to?
I thought we were.
I know, but I realized then we have to move everything.
Mm.
It's just so convenient when all my tools are here. I'm sorry.
Yeah, you should be.
Okay, cool. Check it out. Oops, it's in the fall. Look at that. Okay, so now I just need to put in some of these bad boys. Wait, can we switch to D7100, the scene? Oh wait, this is way deeper.
I don't like your webcam. Makes me look more manly.
You don't like my webcam? You can turn it off. Right, these need to be... how deep do these need to be? From this face to this face is a min distance 7.6. So we want we want something that's M3 by 8. Might as well use these. Do you want to do it?
Do what?
You're going to put this in here, and then this in here, and then in there, and then there.
Okay.
Just 4 bolts.
Just screw them in.
Yeah, just screw them in. I think this is the right one. It's not the right one. Set it down somewhere. Is that the right one? That might be this. No, that's the right one. Okay, that's 6, 8. Two of these. boy.
Is
Oh.
it supposed to go in all the way?
No. It's a set screw. So it just needs to clamp down on the rod.
Oh, yeah.
You know what the pro tip for those is? For the loose part of it, you go like this and then you twiddle your fingers. And that's how you do it the fastest for the initial.
Why
I think
is this one going
I
in
think
more
that
than
one.
mine?
Well, there are different lengths.
Oh, why?
But is this one actually tightened?
No, it isn't.
No, so we need it to be 12. Okay, so can you take that out? I'm sorry. So then let's try 10s. 10.
The other one was fine. It was freaking against the middle.
You could, yeah.
I could hear.
Yeah,
'Cause I timed it
that was a
much.
12. Yeah. Okay, so you're gonna need 3 of these. Okay. So here's 3 M3x10s.
With these two ones, I thought this was 12.
Well, that one's 12, but I think 10. You want it to be as small as possible because it looks the best. So that's why
Do
I'm.
you want me to take this one out? Are you sure? That way it looks better?
Alright, yeah, sure, do it, yeah. So that. 8. And then that's 12. Is it doing it? Yeah, there you go. That's good. Okay, and then the next step is going to be getting some self-tapping screws.
Yeah, it's perfect.
Oh, yeah?
Yeah.
Nice. And so we'll probably want to use...
Oh, wait.
What?
I think the other one split it.
We split it?
Yeah, with the 12.
Okay, yeah. You don't need to be that tight, but it's fine. It's fine.
No, I didn't even notice it. I don't think it was from this one, though. I think it was from the 12.
Yeah.
Sorry.
It's alright.
That's
Yeah,
not alright.
you don't have to give it that much force. Because really, there's already so much friction holding the rods in just from the...
Machine gun on
Yeah. So, you know, just like... Yeah.
it. That's why I didn't by hand for the second time, so I can put it out. Yeah, because I was like, why is this sitting match with it? And that one's not.
I wonder if the rod is... It's okay, it's fine.
It's only like one small layer.
Oh, yeah.
It's not even like...
Yeah, that's
it's
fine.
not going to affect it at all.
That's fine.
It
Yeah,
just-
oh, you know what happened? Is you were... So, when you were tightening it, you started pulling the threaded insert out. Because it had nowhere to go. So the threaded insert started to pull out, and that's why that layer delaminated.
But it won't affect it, right?
No. It's totally fine. And then just do these two.
Okay. Just do it by hand.
Yeah. Well, I would...
I'll tighten it.
Yeah, exactly. Okay, so we're going to want... Let's see, what's the thickness of this part? This part is like 4 millimeters, I think, from here to here. Okay, so we want... Wait, did I lose the part?
What?
Oh, no, I have it. So I could do that right now. Where's the servo? Oh wait, no, I need the screwdriver for that. Let's see, screwdriver. Okay, then this is going to be,
Bruh. What the freak?
what happened? Oh, it came out. That's okay. Just don't bother.
Is can I just...
Yeah, you could try it again, but I think. Well, yeah, you can try it again. So then we just want an M2 by. Let's do M1 1.7 by 4 self tapping. Or no, let's do M2 by 5.
We don't have the magic touch.
It's practice.
How did that even happen?
I don't know. I think, let's see. That hole, let me take that part and hide it. That hole is 0.6, which is 0.4 undersized. It should be able to withstand that force, but I don't know.
Yeah, I didn't even, I barely screwed it in right now because I use my hand to...
Yeah, I mean, it's happened to me a couple times too. But I am going to quickly, after you're done with that, I'm going to steal the servo horn. You're a pro. And don't touch that. That's very hot.
Yeah.
You will burn yourself. I've done
Yeah.
that.
I wasn't thinking about touching a burning hot piece of metal. Wasn't on my list of things to do today.
Oh wait, this isn't what I want. I want this piece. This needs to stay there. Don't lose that. Okay. Okay, so then this needs to be on the back. Oh, I knew I should have given it clearance. Okay. This is going to be a pain in the butt. It expanded or something. Use some pliers. I don't even know why I put this in here for alignment. It's totally stupid. Just gonna break off the little walls of this piece. Huh?
I think they're both doing it. I don't know what's going on.
Yeah, it's fine. Just leave it. That thing's not gonna come out anyways.
Are you sure?
Yeah, I am sure. And if it does, then we'll fix it.
Yeah, because look, it just fell out.
Yeah, just leave it. Don't worry about it. It's all good in the hood.
I think I know what's going on.
What is it?
The screw's too long, and when I'm pushing it in, I can't feel the bar when I'm pushing it in, so I'm continuously going through, and it's too tall, so it's pushing the rod out.
Oh, yeah.
Or whatever this thing is.
The insert?
The insert. It's pushing the insert out. So I just have to be more careful when I'm screwing it in. But I was trying to be extra careful about not screwing it too far in.
Yeah.
I guess not careful enough. Oh, Dios mío.
Ay, Dios mío.
Ay, babe.
Okay, that's pretty in there. And then I'm gonna go. Where's the other one?
I gotta fix another one too, or else it's gonna bother me. I messed up these projects. Oh, Bobby, I'm so sorry.
What the hell just happened? Where did the other? Oh wait, here's the other one. Okay. So we're gonna go from the other side now. Actually, I don't really want to go from the other side. Okay, I am. This is one of these parts that's just like overly complicated. But the thing is, I don't know a way to fabricate your own servo horns. You need some way to melt the plastic onto the thing so that it forms those teeth. I think you could do it with basically the same way as a threaded insert, but like, I don't know. Okay. And then, oh wait, am I supposed to tap this hole? Everyone was making that joke in the comments yesterday on my TikTok. Someone was like, instructions unclear, tapped my own hole, turned me gay. Okay, I need to go tap this hole really quickly.
Can you tap my hole and make me gay?
I don't think that would make you gay.
That one did come out again a little bit, but whatever.
It's alright.
It's okay. Life happens.
Okay. Do you want to come with me?
I guess.
Right. Let's go.
Do I have a choice?
Yeah, you have a choice. You don't. I mean, I'm literally gonna go out there for 1 second. Wait. What does this need to be? I actually need to check that. This is probably 5.5 mils. This is 4.6. So this is an M5. So I need an M5 tap, and I think I use the left one. Okay.
No, thank you.
Okay.
Thanks, Mom.
All right. So now, did I actually put an assembly on this thing? I don't remember what I did. If in the assembly I've sized the. So where's the beam? Where did we put the? Is there a beam there? Okay. So I think the. Wait. I think I messed this up. Let's go to Z. Oh no, wait, hold on. This is 3.5. Why the hell is that 3.5? That, that, That's silly. Okay, so wait. So we actually need you need to put a you need to put in one of those threaded inserts in this. I did this wrong.
Oh, where we just created the top?
Yeah, we just did the tap.
What side am I doing the insert?
Oh, you're gonna do it.
This right here?
Uh,
Where the images coming out?
wait, I installed this the wrong way.
Oh, do you want to take it apart and put it on the other side?
Yeah. I mean, I don't think it matters.
See it?
It...
Can I? Oh, yeah, you did do it the wrong way.
Yeah, I did it the wrong way.
Okay.
Be careful, those are really small parts. I would do it over the table. It's gonna fall off. The problem with self-tapping screws is you kind of widen the hole when you do this, so kind of a fail, but I'll own up to that. You know, we are triaging this issue.
Did you do it wrong?
Wait, did I do it wrong? No, I didn't do it wrong.
Yeah, you did it right.
I did it right. Why was I tripping? That's so
I
weird.
looked at the photo right now and it's correct.
Yeah, it is correct, isn't it?
But which side do I
So you're going to put the threaded insert on the front face.
Okay. That would have been annoying if I had taken that.
I know. I'm glad you double checked.
Yeah, I was just bullying you. I didn't actually know if you did it right or wrong. Wow. Wow. And the same insert that you have out.
His design is so fucking cool. Huh? Yeah, those are the right ones.
Okay.
And hopefully it just stays in and it doesn't work itself loose, because otherwise what I would do is I would make it 2 millimeters thicker, but I would make it a blind hole, so I'd put a threaded insert into a blind hole, and then you can tighten down at the end, and it's not going to go anywhere because of the friction of the PLA at the bottom of the hole to the bolt. But we'll see if this works.
Okay.
And unfortunately, I can't play music, so no sweatshop music because of copyrights.
There we go.
I can mute everything. Okay, beautiful. Ow, fuck.
Oh, gosh.
Wait, you did it on the... Oh, you did it on the right side.
Yeah.
I'm sorry. I keep getting confused. Okay, so now what we're going to do is we're going to put a...
I have a pimple, it hurts. Can you pop it?
Wait, hold on. It's going to be like that, I guess. Okay, so can you get me like an... So this is 5, this is 4. Can you give me an M3 by 10? And it's the left side ones. I mean, it's either side, but specifically the left side. And I just need one of them.
Which is left side. What does that mean?
Well, so there's 2 sets of M3 by 10s. M3 by 10, M3 by 10.
Oh, and you want the left one?
Yeah. I mean, they're identical, but I prefer the socket head ones. Yeah, they're 2 different geometries.
What if I just drop these everywhere?
That's fine. We can pick them up.
So they want one?
Yeah, just one more. And then I need... Well, I'll take this back here. Of course. Of course I would! Wait, I'm a little too loud. Alright. So, we need this to just slide through here like that. And it's supposed to just hang on. Oh, fuck, I did it the wrong way.
Oh, yeah. Men. Coffee emoji.
Can never do anything right. Okay, yeah, we'll see if that stays in. That's not gonna work. Wait, this whole thing is not gonna work. I need to I didn't... You know what's crazy? One thing you'll learn when you do designs is if you ever leave a part out of your design, that's going to be the part that... So what we're going to do is we are going to...
You didn't finish your sentence. That's going to be the part of
What?
What? That's
What?
going to be the part to what?
that's gonna cause it like an interference and like cause the design to not work. Can I have the screwdriver?
You're having the heater.
Do you want the heater? Sit here.
In the sunroom right now.
I know.
Okay.
Fuck, these parts are so
You want
small.
help?
I don't know how people build watches. Watchmaking sounds fucking awful.
Do you have a magnifying glass? Do you want help?
No, I got it. Now that it's in, it's fine. It's just getting it started. That's the hard part. Just getting it started. Getting it started is always the hardest part. Yeah, you know what's actually the hardest part? Fucking finishing. It's easy to start. You can start anything. Finishing. Okay, so it's not tightened down, so it can flop around. And then the hope is that this doesn't just come loose. But that's kind of like bad design practice, I think. I think most real engineers would say that's a terrible design. So now we're like basically ready to attach this to here. And then we just need to put a big ass threaded insert into there. And it's the biggest one, I think. Let's see, how deep is that hole? Can you figure out how deep this hole is? The way you do it is you select the two faces, and then down here it will tell you the measurement. So, almost. It's so you're trying to find the distance from this hole to that hole to find its, because those are parallel faces.
How do I get this one?
No, this face.
Am I not doing it?
Well, this is.
You do it.
Okay, I'll show you how to do it. So the way you do it, space deselects. So if you do this and this, it's an 8 millimeter deep hole. So 8 millimeters, and what's the diameter? If you click on if you press space, it deselects everything. Now click on the circular edge. And then how big is that?
7.6.
7.6. And the depth was 8?
Yeah.
Okay. Come on, you bastard. Heat up. Heat up. Peter, did you remember to take out the trash? Hey, Peter. Wow, there's so much more brass in these ones that it takes forever to sink. Just wait and wait. Okay.
Show it to your camera.
Oh yeah. Okay, so here it is. So now we're gonna. It's still kind of blurry.
It wasn't when you twist it again.
What?
You had it right.
I know.
There.
There we go. Okay, so here is the part. Now we just need to put a big, I think M6 bolt in here. And then it should, when this thing turns, it will pull that part up. So let's just get a big M6 by, yeah, let's just do M6 by 30. That's a big ass bolt, man. This might be 25. I don't know what the distance is. Sorry. You definitely don't.
The people want to see.
There's no one watching.
It doesn't matter. You gotta get better at your
I know. I
video
mean, that is
skills.
the craft, is like showing it off. This thing is is fucking sick. We forgot all the springs. I don't have the springs. I need to order the springs. But this is definitely going to work. So now I'm just going to... where's the screwdriver? Let's just get this screwed in. Freeze. This thing is sick! Look at it! That's such a better design than what I had before. Do you wanna try it?
That's cool.
I think let's see, what's the limit? That's pretty good. That's kind of the travel we would expect. This design is so fucking cool. I like this so much more than this. Look at that. Look at that. That's dumb as hell. That's dumb as hell. That's uninspired design. Okay. So now it's time to install it. Oh, but the thing is, we actually have to rebuild this whole thing because we forgot the pen, the pen thing. Do you want to design it?
No.
I'll show you how to design it. It's easy.
I'm too tired.
You're too tired. That's fair. That's so fair. All right, you want to be done?
That's okay.
Okay.
You want to finish? Are you gonna finish today?
I was planning on it.
Okay, then yeah, continue.
Okay. So all right. So let me just hop into CAD really quickly because we need to do some research. I can give you the heater.
I'm fine.
Just two hobos standing by the fire. Oh wait, where the hell did this? Wait, I got this all fucked up. Okay. You can't feel it? Why don't you move closer? Sit next to me. Alright, so what I forgot to do last night, which is hilarious, is the actually only part that the whole part of this design is totally... Well, now we can do this, too. Do you prefer it there or down there? Yeah. Oh, we can kind of share it. Okay, so I want to make two modifications. So I'm going to switch to this part. I'm going to go to... I guess it's this sketch. No, it's not that. It's this sketch. So this, we don't want it to be 5 down. We want it to be from this midpoint, like this. This is a Q. Then we're going to delete this, and then we're going to do this, this, and then this is going to be I, which is incident, and then we're going to delete this. I should have made this a mirror. Oh, hey, look, I'm getting blue again. See, when a sketch is no good, you can see blue. Yesterday, I had to, like, guess at where all of the... So this should be a horizontal constraint. Okay, so then that's redone. So we fixed that bug. Now what we need to do is we need to go onto here, sketch, get the midpoint. What we want to do is we want to basically draw a circle like this, and a circle like this. And then we're going to make this wall thickness, I think it's like 2. I forget what the geometry is. We could go back and look at the other one, but it's really not that important. And then we want a line coming from the midpoint of this thing, and it's a construction line. And then we want to say that these are coincident. And then we basically just want to constrain the distance from here to there. I'm wondering... Do we want it to be 1 part or 2 parts? Let's just say that they're... What if we just did like that? Okay, now it's just that this inner diameter needs to be 15. Alright, so this is a fully defined sketch. So now what we want to do is we want to take this and this, we want to extrude it, and we want to add, flip the direction, and then we want to make it 24. And it's not a new part, it's merging with the pen holder. Okay, that's a pretty simple part. And then all we need to do is we need to add a big. We're gonna make it an M6. We're gonna add another one of those M6. So we're gonna do a plane. We're gonna make a plane. That's a tangent plane. Wait, where did it make it? See, but it made it on the wrong side. Flip normal. No, flip alignment. There we go. You can select an additional point. I think I can just select this point. Okay, cool. So now what we're gonna do is we're gonna sketch on here. Then we want to use both. We want to use this. Then we want to get a construction lines here, like this, and then we want to draw a C, and then we want this to be. Oh wait, the wall thickness actually needs to be bigger. So we need to go back to this sketch, and we want the wall thickness to be. Well, if I'm making it an M6, I don't really want it to be. Right, I want it. If I'm making it an M6, I think someone said 2 times the diameter, but that's ridiculous. I think if I make it 4, and then I tap it, I'm gonna say it's 4. It's gonna look beefy as hell. And then and then this needs to be an M6, just 6 millimeters minus tap hole reduction. And then we're gonna do this. And the weird thing about this is that if you do, you can't use up to next on cylindrical. It doesn't work. But up the face works. Okay. And then what we want to do is we want to add a helix to let myself know that this is a tapped hole. And then the pen goes in there, 15. The problem also is well, let's try this, but 2 holes would probably be better. Because 2 holes constrains it.
2 holes are always better.
Let's do 2 holes. Might as well. We can always just use 1. So let's delete this, and then let's just does this have a verticality? Oh wait, here. Let's get that verticality. So now it's centered in the middle. And then what we want to do is we want to make this. Let's see. The width of this is 24. So if we want to evenly space them. If I do this and copy and paste it, okay, I got another one. Oh, I don't know about all that. Wait, what the hell? Is there a weird tangent constraint on that? No. Okay. So these are both equal. I think what I can do is I can do this. Yeah, let's do. That construction? Okay. Okay, but this is... Okay. And then I can just go bop, 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 bop. There we go. So that's equally spaced. And how long is this? 4. That's pretty good. Okay, so then we just do this, this, and then wait, when we do the extrude, we need to add this face. And then we have to do each helix individually because why the hell? Why? I don't know why. But okay, so now we have 2 holes for the pen. So now we can export this and print this part. So it was fun building that, but it's like, why didn't I just start with this? We'd be so much closer to being done. Export pen holder. Pen holder in parentheses with pen holder, you know. This version actually has the pen holder in it. Silly boy goofy boy goofy. And then I think honestly, I've kind of come around and I feel like even though it's a pain in the butt to have to remove the supports, to have the sanity of like, okay, at least the hole is actually not an oval is like kind of nice.
Those thingies that we had to peel out.
Yeah, those
that
are the
was kind of fun.
You liked it?
Yeah.
I once printed like a figurine, and oh my god, the supports removal was the worst thing ever. Okay, so so that's what it's gonna look like. So you get to remove all the supports. All right, so it's gonna take 38 minutes. 38 minutes.
Do you have anything else to do in 38 minutes?
I don't think there's anything else that we have to do.
Can we snorkel for 38 minutes?
Yeah, sure.
And then I'm gonna go home.
Okay. Get ready for class. Guys, it's the first day of school. It's the first day of school. Everyone's so excited. We're all so excited.
Yippee, yippee, yippee.
School is going to be so fun. Guys, I'm learning Master Cam.
Woohoo!
Master Cam. I'm going to be an expert at Master Cam. Which is like honestly kind of lame, but the class after this is going to be sick. The multi-axis class is only taught in freaking whatever. Okay, so why don't we just keep on the stream? We're going to mute the stream and then we're going to play the video. What the hell? Alright, you know how a 30-minute 3D print takes so long. Alright, I reprinted the part. Let's just get to it. You know, just fucking. Oh yeah, there's 2 holes. Okay. God, it really is so cold in here. Okay, supports removed. Now I gotta go tap this. I forgot about the tap. I gotta tap 4 holes. Let's see, what is the diameter of yeah. See, that's the problem, is you actually have to go to the sketch on these. It's 5.6, which means I'm using a M6. Jesus. Okay. All right. 6 and 3. I'll be back. I gotta tap. Gotta tap. Okay, so I gotta test what pitch my M6 bolts have. So let's see, M6 by 12 is probably the smallest that I have here. Let's see, hopefully it's 1. But it could be something else. So what you do is you use this little tool that has a little thing on it. Okay, cool. So it's 1. Nice, nice, nice. I really should make a... That's actually not a bad idea, is to have a shelf of all my bolts. Because the thing is, it's nice to have a little case, but it's also nice to just have a shelf. Okay. The parts have been tapped. I need to take a shit. I'll be back. Okay. I know this is a very uneventful stream. All right, but we're now ready to. Let's see. How do we want to do this? We probably want to do it like this. So let's just switch to. Okay. Damn, she tightened this way too tight. That's crazy. Really, really tight. Yeah, it doesn't need to be that tight at all. That's okay. It's just aluminum rod. It's literally like $10. So let me just pop this bad boy off. Pop this bad boy off. Oh shit, did I tap those? Yeah, I did. Okay. Okay, I'm gonna try something new. I'm gonna try to take this thing out. I don't know how I'm gonna do that. Let's try. Oh really? I thought you wanted to stay.
No, I said I have to go.
Oh, okay, you have to go? I'm sorry. I misunderstood. Still streaming. It's okay, you're not in shot.
You have to go be okay.
My mom is making rice right now and tofu. She's making. She can make some for you. You can stay. Wait, Mom, can you make enough rice for both of us? And then we'll just. You need to leave at 5, right? Okay, alright. So let's do it. Let's get this thing done. So, what we do with parts like this, we yoink them. Wow, that thing is still hot. Oh, and the soldering iron's still on. Okay, so I need to put this in.
You wearing eye protection?
From what?
Is that cutting away at that or melting it? Okay, let's see. I was getting tofu.
Alright.
Do you want onions and bell peppers?
No. Okay, so now we are ready. This part goes like this. We can just put these linear bearings in. Take these short screws. Get them started. Okay. Those aren't going anywhere. Okay, so now we can go like this. Take this bad boy. Okay, that's in. And we just need the 12 mil. Oh yeah, this thing popped out. Whatever, we'll deal with it another time. It's honestly not that important. Okay, so now we just gotta slide this to the bottom, slide this through here, and then tighten. Okay, so now it works and it has a pen holder. So now we should be able to put a Sharpie in here. I am worried about how tall it is. Did we get an M16? Oh, I might not have given enough space here for both of them. Yeah, I didn't think about the hex head. But that's pretty rigid. So that's kind of a fail, but it's pretty rigid. So you can put these back. Okay, now we just gotta reinstall it. Alright, so let's do this thing. So wait, hold on. So we need to take the belt off, which actually we should take the, well, okay, so see, I don't know what to do about all these threaded inserts. It's like, what do I do? Okay. That's not in all the way. Come on. There we go. There we go. Okay, that's pretty good. Look at how over-engineered my device is now. Yes, look at how over-engineered this device is now. And look at this wobble, bro. Look at that wobble. We definitely need to put it on a board. I do love having a lot of parts. Having a lot of parts is so nice. Like, you know, like the self-tapping, the bolts, the threaded inserts. Having the parts and the tools is so useful. Okay. So it's time to just reconnect and do tests, right? I mean, this is it. We're ready to test this bad boy. Let's test it. Let's test it. Let's test it. Let's test it. So guys, the biggest advantage of this new design, the biggest advantage of this is that there's no way to get this thing in a state where I have to like fix it manually. Like there's no error state here. Like before, the flap could flip around to the other side, and there was just no way to fix that. Oh shit, that was plugged in? That was no good. That's crazy nothing shorted. I could have... Wow, that's crazy. I just left that plugged in. Okay. So what we're going to do is we are just going to see if we can connect to it. Alright, so it seems like it's good. We're going to try to home it. Oh shit, there's no belt. Hold on. I knew I was forgetting something. Okay, so we need to flip this over. Okay. Come on, get in there. Get in there, you bastard. Let's loosen it by one tooth. No, that's too loose. That's way too loose. There we go. Alright, at least it's buzzing a little bit, so it's got some. Okay. This flap, oops, gotta get this out of the way. Get this out of the way. Okay, we are gonna need to do a cable management thing because this thing is, the cables are definitely a problem. All right, so wait, let's try to home it now. Hold on, let's do this. And then I actually want to, let's just cut this off. Let's see. It's good enough. All right, so it's off the axis. Now we should be able to just home it. Okay, cool. So now we should be able to take the cap off of this thing. This is in the bottom position. So you need to loosen it till it's, ooh. So it's like kind of like right there. See, that's no good. Wait, but we should use the bottom one. So if you see this, there's 2 holes. And the best solution I messed up the holes. Okay, that's fine. I think I will want to add more rigidity to this setup, but it's actually pretty good. Alright, so let's just try to draw. So let's close the serial monitor. Oh wait, I don't know if that closes it. Okay, let's do that. And then let's try to run penis.py or whatever it's called. Or let's just do square. So we go to run.py. Python, what the hell? Python run, oh wait, run.py. That's it. Because it didn't move it down, but that's okay. So let's do wait, what we should do is there we go. Well, it definitely works, but it's you kind of have a rigidity problem, right? I mean, the fact of this. Let's loosen this up and get this to go as. See, that's the problem, is we can't do it on the tapered part. So that's kind of. Okay, let's try to do it again. Wait, what happened? What's happening? Still deflection issues. Wait, let's just try doing big penis again. Yeah. We need to bolt it down. I need to redesign all these parts. Like a big plate. Like, look at how much this flexes. This thing flexes so much. And then this thing moves, so we need to have a way to tape down the but I do want to know if I'm all the way over here. It can basically do okay, and then let's go all the way out there. Yeah, so this thing is like perfect for like one page. I love that it just works though. It's so hype. At some point I do need to hop into CAD and I'm gonna redesign. Well, let's do grid of dots. Wait, hold on. Actually, what I want to do... Okay. Yeah, so 110 is actually kind of perfect. It's like... 110 is like kind of perfect. 140 is down. Yeah, that's too far. But it works so well. Dude, this mechanism works so well. I just assembled the newly designed Z-axis. It now uses rails and linear bearings, and I can just raise it up so easily. And it's so reliable. And the other thing about this design that's so much better than the previous design, which used this part, is that before, that flipper would get on top of this part. So then I'd have to like hold it up past the spring, and then this thing could get back to its original position. But now there's no such error state in this design. Plus, it's so much more reliable. It's probably a little bit heavier, requires more parts. It's not fully 3D printed, but and eventually I think I will put springs here to at least have something pushing it down. I don't know if I even need springs, honestly. But yeah, so that's what it is. Alright. Short video that I can post. Alright, what do we need to do now? Okay, so we just need to make a thing called raise, and all it does is send S110. Okay. Okay. Wait, what? It didn't work. Oh, you know why? Because you have to send... Okay, so you know what the best thing to do is actually just first it needs to write there we go. So we just needed to give it the unlock command, and then it did it. Okay, so now alright, so now we can do a grid of dots. So let's do, so wait, we want it to be close to home, like there. Okay, Python grid of, Python raise grid of dot. Oh no, not raise, run. Let's try to, we're going to regenerate, generate, what's the thing that generates the grid test? So we want this. We want to make this like 90. Python grid test. Oh wait. Python grid test. Okay. Python run grid of dots.g code. Okay, this is a grid test of the new Z-axis that uses linear bearings and this cool little thing that allows this thing to rotate about this point. So it's turning rotational motion into linear motion along these bearings. And we're getting way more reliable. And the thing is that's sick about this is there's no error state. In the previous design, right here, the flipper could get on top of this piece, and then it would be in an error state that would have to manually correct. Here, there's no possible way for it to reach an error state. It's basically always going to work. So this design is just like kind of superior in every way. It's a little bit bigger though, but I think it's so much better. I mean, look at how reliable this grid test is. This is the rest of it, and this is the code. Well, I mean, it's part of the code. It's time to post my video. It's time to post my video. Test of the new Z-axis that uses linear bearings and this cool little thing that allows this thing to rotate about this point. So it's turning rotational motion into linear motion along these bearings. And we're getting way more reliable. And the thing is, the sick about this is there's no error state. In the previous design, right here, the flipper could get on top of this piece, and then it would be in an error state that would have to manually correct. Here, there's no possible way for it to reach an error state. It's basically always going to work. So this design is just like kind of superior in every way. It's a little bit bigger though, but I think it's so much better. I mean, look at how this is a grid test of the new Z-axis. Wow. Look at that. That's art, baby. That's art. A much better design. A much better design. And the drift from this is only an account of this thing shifting back and forth. Okay, I guess before I put this on a wood board, I should probably redesign these parts. I think I want the stepper. You guys can't even see it because of this thing. I guess this is probably the best place for it. Well, that's not a good place too, because I always work there. Ugh, this is why user-side compositing is the best. I don't know, but nobody wants to do that. Alright, cool. Moss code. Moss code, buddy. Moss code. Okay. Alright, so we can do python raise.py 140. Let's see if we can how low we can get this thing. Can we make this like 0.5? 1. 1.5. Damn it. 1.75. There we go. Okay, I guess it has to be 2. GRBL takes so long to initialize. I'm kind of surprised by that. Oh, you know why it didn't short or do anything weird? It's because I probably had the light off. That's probably what it was. Yeah, I'm trying to stream once a day, and I'm trying to post a short once a day. So I got 365 streams and 365 shorts. I'm thinking that if it's all good and hard work, it should work. I mean, you just got to make good stuff, I feel like. I wish YouTube instantly told you where the subscribers came from. Hop into CAD, making my way downtown. What's going on TikTok? What the hell? Oh, 25. I don't even know how much I need a I mean, this is pretty much a CNC machine, you know? We're at 307 subs. That's pretty good for the new year. I don't want to extrapolate with that because that's nonsense. Because it's mostly just got to keep grinding, I feel like. His is nice. His uses a stepper motor and then another linear rail. I was thinking, how do I rig it? How do I rig it so... Oh, I thought I could pan around that thing. Dude, how much does he make on Patreon? He probably makes a good amount of money. Actually, he doesn't, dude. This guy makes like no money. Hopefully his AdSense is pretty good. I don't know, man. He probably doesn't make that much money. I mean, okay, I guess he has to supplement it with ads. I guess that's just the game you gotta play. You just gotta be sponsored. But sponsorships, it's like, I don't even really want to do that. But also, I do want the money. Because the money will allow me to build way cooler stuff. So if I just put up with it, I don't know. I want to see the laser engraver. The laser engraver looks weird.
Thanks to the open source modeling.
Wow, look at that. Lead screw, 3 rails. Probably bearings in there. I don't know. It doesn't even look like there's bearings in there. And then, okay, and then this is the laser. Let's look at the laser module. Let's see. Can a laser cutter do steel? Let's look up. See, it's all just the whole machine, but I don't want to buy the fucking machine, dude. That's for people who are like, who just want to like try to make money with dumb art, AI slop, people who don't like to build. But what I want is the actual module there. How do I get the? Let's look up CO2 laser. Ugh, they only sell the... It's probably a safety hazard for them. Let's look up... Okay, well, actually, he'll say...
Server, which has options for laser engraving and SCARA robot setup. For generating the G-codes, I'm using yet another open source software, Inkscape, and a plugin for it called Inkscape Laser Tools. You can generate G-codes with counters only, and with counters and infill from the same vector image, and we have various options like adjusting the laser beam, travel speed, infill speed, parameter speed, laser on and off commands, including PWM control of the laser and so on. Nevertheless, now I will walk you through the entire process of setting up a SCARA robot to work as a laser engraver. We will take a look at the
This
design
is so
of the SCARA
crazy,
robot,
man.
how to install and
Oops.
each trigger
I've
was
never done something with inverse kinematics.
interfering with one of the nuts at the bottom of the arm, so the arm couldn't reach its full motion. I simply removed that nut, replaced it with threaded insert, so that when securing back the part in place, it won't stick out. And that's it. The SCARA robot is now ready to work as laser engraver, but of
This thing is fucking
course,
cool,
first
man.
we need to install the firmware to the Arduino board. As I said, I will use the Marlin firmware.
I know how to
which is one
build
of the
this.
most
This is
widely
pretty
used
simple,
open
man.
source firmwares for 3D
I love the
printers,
lead
which
screw.
also
I
has
wonder how he
options for
I wonder how he
laser engraving and SCARA
attaches the
robot
lead
setup.
screw.
We can download the Marlin firmware either from its official website or from github.com.
This is so
Installing
cool.
Marlin firmware to the Arduino Mega
Oh,
board,
wait.
we will use platform IO ID instead of the Arduino ID. As the Marlin firmware is big and complex, the Arduino ID might sometimes give errors and not be able to compile it. Platform IO is built on top of the Visual Studio Code editor, and it can be installed as
Editor.
extension to it. This means first we need to install Visual Studio Code, then search for the Platform IO in the extension manager and install it from there. Once the installation is done, we can click the Open Project button, navigate to the Marlin folder that we downloaded and unzipped, and click Open Marlin. This will load all the
Alright. I'm gonna end the stream. Okay, 3-hour stream today. Kinda on the short end. I'm gonna go eat. I got class now. I don't even know. But I wanna cut steel or like procurement, bro. Getting good at procurement actually kinda crazy. Baby, see, they only sell the whole thing. Honestly, I'm like kind of ready to move on. Okay, well, in any case. Dude, Beaver makes so much stuff, it's crazy. .2 kilowatts? Wow, that's a beefy ass spindle. Is that just for the spoil board? What is that? No, it's not. Oh, okay. That's sick. I mean, for me, I would want. So okay, here's the thing that's interesting to me. It's like, I should do like a review of like, is it better to go like a mill or a router? Wow, that's a huge CNC router. They all get these huge aluminum extrusions, man. I want to do that. This thing is sick. So, dude, the person that I really like is Marius. Dude, this guy is fucking awesome, man.
Over the years, I ran into a few of my holdowns with the CNC router. They're wood, and that doesn't matter, but now most of them are worn out, and I need replacement. I cut some scrap off into strips.
See, because that's the thing, is this guy is so good at wood. I wish I was this. I wish I had a setup for wood like this, because wood is such an amazing material. Wood is one of those materials that it's like, it's light, it's pretty strong, it's recyclable and environmentally friendly, like, it's cheap. Oh, wood is awesome. I don't have a table saw, but I would love to get the bandsaw going. We have a big-ass bandsaw behind me, and we have a small bandsaw. Dude, this year is the year that I really get a nice home shop. Like, I have a pretty good home shop for, like, some little electronics, for 3D printing, but it's time to get good. Anyways, that's